We are working on the bit by bit project from the YByte Python curriculum available at www.ybyte.in. We saw previously how we can do counting with binary numbers, uh, but clearly we need a quick way to, let's say, convert between binary to decimal, or vice versa. So we learned this in mathematics. For example, one way is to just repeatedly divide the number by 2 and keep looking at the remainder. And you can from there you can get the binary representation. But we will see this from a Python perspective. It turns out Python has some pretty interesting commands to, let's say, do this conversion. So here I am in my Python environment. Let's say I want to convert, let's say, the number 4 to binary. All I need to do is to bin 4. And in fact, I get a string. So let me just assign this to, let's say, A. A is a string. I get a string. So A is 0B, standing for binary, 100. Now 100 is 4, because remember, it's 0 times 1 plus 0 times 2 plus 1 times 2 to the power of 2, which is 4. In fact, you can convert any number this way. Let's say if I try 42, so A is going to be a little bit longer, but you can work out it's basically 2 plus 8, which is 10, plus 32. So yeah, that is indeed 42. So any number can be converted to binary by just say giving, let's say, an integer. So I can give a large number as well. Let's say I say quite long number. If I look at A, obviously it's a long string, but it's also 0B, and notice everything else thereafter is 1 and 0. So that's why it's a binary. Now if I want to convert the reverse, let's say, so if I want to do, let's say, B is, for example, I want to see what is in decimal, so I can just use the int command A, and I just need to give base as 2. So when I do this, B predictably becomes wherever I came from. So basically bin converts from, let's say, an integer value to a binary value, and int with the right base gets me back to, let's say, the decimal value that I started from. Now in case of int, the A, or let's say the first argument, must be a string. And if I, let's say, do not give, say, the base, then it's treated as base 10. And we have seen this before, right? So when I do, for example, C is, say, int, let's say 82, let's say 82. If I make it as a string, then this will be 82, because, well, that's in base, base 10. But if I were to give, let's say, int 82 in base 2, of course, this will give me an error, because remember, in base 2 binary I can only have zeros and ones. However, I can indeed convert, let's say, a long string like this, say 100, 0 1 0 1 1 1, quite immediate. I mean, not immediately obvious what it is, but if I look at, let's say, convert that to an integer base 2, it will tell me that happens to be 279, and we can actually work it out. So this becomes quite a, let's say, convenient way to convert between decimal and binary, and vice versa. In fact, it turns out that there is one more very simple way of doing this. So I have taken my Windows calculator, that comes built in with Windows. I just go into what is called the programmer mode in this. Now this is pretty cool, because when I, for example, type a number, let's say 78. So when I type, so I go into the programmer mode. Now when I type, for example, 85, it immediately tells me that this is 85 decimal, and that is 0101 0101. In fact, I can add more digits to it, and it just tells me the conversion here. In fact, it also gives me hexadecimal and octal values, and you can look at it. So this becomes a nice way of, let's say, let's say, converting from binary to decimal. And in fact, we can, so this becomes a very nice, easy way to convert between, let's say, decimal and binary numbers. In fact, we can also input the whole thing in binary. So if I go and select, let's say, bin, notice this, the number I've added, and only 0 and 1 is highlighted, and that makes a lot of sense. So for example, if I go into, let's say, 1, say 0 1 whatever, so 1 0, so 0 1 0 0 1 0 1 1, that happens to be 75 in decimal. So it's kind of really nice conversion back and forth, and it presents it quite nicely as well. So it's easy to, let's say, look at it, right? I hope you found this interesting. Once again, notice that our approach is decidedly practical. We are focused on building the activity that we are going after, which is the, the bitwise operators being used for that, let's say, LED patterns. But in order for us to understand, we need to understand this conversion quite well. That's why I'm showing you these tools, because this can help us a lot in making our learning much more smoother. And that's the philosophy at Vibyte. Build activities that illustrate concepts because they make understanding that much better and they make programming so much more fun. Look at our website www.vibyte.in because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.